warning device team. If you can come up, you'll be presenting first. And on stage left or stage right is Eric Stoutzer's team for Portable Remote Interactive Platform Behavior for Behavioral Analysis and Speech and Language Disorders. So if you guys can be at the ready, and then as soon as this team is done, when you exit, this team will come up and I'll be calling up the next team. So let's give a great big hand to our second look vehicle safety warning device team.
Hello, my name is Diana Elatello. I'm in electrical and hands-on engineering students at UTDallas. And I was the team lead on this project. I'd like to introduce my team members. Albert Zillo, who is an electrical engineer, and Eric Cuevas, who is also an electrical engineer. Our device that we designed is called a second look. Its primary purpose is to be able to notify caregivers that an individual, either a pet or a person, has been left in the vehicle and an unsafe temperature has been reached. Hypothermia death occurs every year. We hear mostly about the children that are left, but also other individuals are at risk. This includes elderly and disabled who may have been left in the car for just a few minutes while somebody ran in to a store not realizing how quickly the temperature raises, as well as pets. So this semester what we did is we built an actual device based on last semester's research. One of the main methods that we used to determine that there was life was to look at a rise in the CO2 levels within a vehicle. And that's primarily what we were able to do. The graph here shows that we had a 6.5-pound dog, which was actually below the threshold. Our original goal was for a 5-kilogram individual or an approximately 11-pound individual. And we were able to see within 15 minutes, you could see a significant rise in the carbon dioxide level within a vehicle. And this was when the dog was in the carrier. The rise was even greater when they were loose in the vehicle. So based on that, we were able to set a basic parameter to check the CO2 rise within the vehicle and compare it with past results. When we saw a rise of, in this case, 20 parts per million, we were able to easily detect over a 5-minute time period that there was life in the vehicle. So with that, we then sent our microcontroller, which was the Amino Mega 2560. We sent that controlled everything for our design, and then we were able to use the Amino GSM shield to send a text message. We did have a couple alternative backup methods for our design. Was to look at motion detector and to use that in case there were windows that were left open, and in which case then we found that with the motion detector we were getting a lot of false negatives and false positives, but so currently the CO2 levels were the most accurate. And we did have some basic challenges this semester. We lost a team member halfway through. Our programmer had some difficulties and had to drop out, and we had wrong sensors sent to us. So basically, though, we were able to design what we had. We do have recommendation for further testing on everything to make certain that this is something that could be made ready to market. But this product overcame many of the challenges that are seen in devices that are currently on the market. It can be placed anywhere in the vehicle, and you don't have to have it set for each individual person. You can place it in an area where it won't be spilled on by sippy cups, by children, or other damage from collisions. And so this is really a way that we can overcome the device flaws that are on the market. If there are any questions? Yes?
So did you develop any new hardware or any device drivers for this project, or was this basically where you took off the shelf Arduino components and wrote software to get them to work? Was this more of a systems project, or did you actually?
It was more of a systems project. We weren't sure whether the off-the-market, off-the-shelf CO2 sensors were going to be sensitive enough in the detection levels. So we did have as a backup to actually design something for that. With the motion detector, since the one we chose was not very reliable, we do recommend either looking into other motion detector methods as a backup in case somebody leaves the window open considerably. You can still have a hypothermic situation within the vehicle with the windows open. And so that would be a recommendation. That's something that would probably require more precise provider, the other option we were looking into was actually being able to hardwire it into the vehicle and have it basically mount on the roof, on the ceiling where you put your light, so that it could be kind of an all-around device that is out of the way, it won't necessarily be touched, and you don't have to worry about the power regulation at that time. We did have to reallocate some resources of personnel because of the loss of the individuals, so we didn't get as far on the power research as we had hoped, but we do know that we have been able to test multiple methods of powering it.
Thank you very much, Diana. That's, appreciate this.